All right, this is a recap of a very important topic that we covered earlier, in which we talked about exponents. So let's see. Let's talk about exponents. And I want to make sure you're super solid on it. So exponent simply means when I say something like, let's say 2 to the power 3, it means 2 times 2 times 2, and we do this process 3 times. So in this expression, 2 to the power 3, when I said it, this is called the base. This is what you are multiplying itself, and this is called the exponent, which is what how many times you're multiplying. So let's give some more example. So let's take a different example. 3 to the power 2 is simply 3 to the power 3 equal 9. Well, let's say this 2 to the power 1 equal 2 multiplied just one time. 2 to the power 2 equal 2 multiplied by 2 twice. 2 to the power 3 equal 2 times 2 times 2 3 times. And then finally 2 to the power 4 equal 2 times 2 times 2 times 2. Notice what is happening, that each time you increase the exponent, you see this 1 to 2, it moved. When I increase the exponent from 1 to 2, I multiplied by 2. Likewise, if I change the exponent from 2 to 3, I once again multiplied by 2. And finally, when I change the exponent from 3 to 4, I once again multiply this thing by 2. Correct? You can look at it other way. You can say, what is happening when I decrease the exponent? Well, notice when you go decrease the exponent, you're dividing by 2. Once again, when you decrease the exponent from 3 to 2, you're dividing by 2. And you divide by 2. And that gives us a very counterintuitive thing, which seems weird. It seems totally weird that what in the world is happening, but it is so cool that this works, is that if I say what is 2 to the power 0, well, I'm decreasing the exponent from 1 to 2. Well, I simply have to divide by 2 and I get 1. That means 2 to the power 0 equal 1. By that logic, 5 to the power 0 is 1. And 100 to the power 0 is 1. And 0.1 to the power 0 equals 1. Make sense? All right. Now let's talk about one more thing, which is going to be, let's see. I need to insert a slide. How do I insert a slide in this? All right, got a new slide. Okay. So we talked about exponents. Now let's come very, very useful theorems on exponents. And we have already covered that. If I take, let's take 3 to the power 3 is 3 times 3 times 3. And if I say 3 to the power 2 is 3 times 3 twice, correct? Well, what is 3 to the power 3 times 3 to the power 2? Well, it is going to be 3 times 3 times 3 from here times 3 times 3 twice from here. And then if I calculate the whole thing, how many 3's do I have? I have 3 5 times. So this equals 3 to the power 5. Look what happened. 3 times 3 multiplied by 3 times 2 gives you 3 to the power 5. And the reason is, as we discussed, this gives you multiplication of 3 by itself 3 times. This gives you multiplication of 3 by itself 2 times. And when you multiply them together, you get total of 5. So does that make sense? So what we can then say is that for every base x times every exponent a multiplied by x to the power b, it is going to be x to the power a plus b. Now we have talked about x as a whole number, right? But x could be plus 1, plus 2, plus 3, but it could be minus 1, minus 2, minus 3. Well, it could even be a fraction, 0.1, 0.003. It could be, well, that was decimal, or it could be 2 to the power 3, or some other fraction, 5 to the power 7. So as an example, if I want to say what is for example, well, let's say 1 over 5 to the power 2. Well, it simply means 1 over 5 multiplied by 1 over 5, 1 over 25, right? If I can say what is 0.2 to the power 3, it's 0.2 times 0.2 times 0.2. Well, you can write it down, you can figure it out yourself, but essentially I have 8 with decimal here, and because I've got 3 points, 3 times decimal, tenths I'm talking, I'll have to move the decimal to a lower value 3 times. 1, 2, 3, so that gives you 0.008. Finally, it could be negative number. Negative 2 to the power 1 is negative 2. And by the way, negative 2 to the power 0 is 1. Negative 2 to the power 2 equals negative 2 times negative 2, which becomes positive 4. Negative 2 to the power 3 equals negative 2 times negative 2 times negative 2 equals 8. This negative cancels out. Yeah, you know how negative times negative cancels out, right? So these two negatives become positive and you're left with one negative, right? So notice how the power of negative 2 is changing from 1 to minus 2 to plus 4 to minus 8 and so on. So the sign is changing from minus to plus to minus. So the power changes. So if it is a even number of power, so such as 2, the sign will be positive. If it is a odd number of powers such as 1 or 3, the sign will be negative. Does that make sense? Okay. So finally, one last thing, property of this thing that we just briefly talked about, which is to say what happens if I do division. And we talked about if I have 2 to the power 3 multiplied by 2 to the power 5, it's 2 to the power 7. Always works. 100 to the power 3 times 100 to the power 12 equal 100 to the power 15, right? Likewise, if I say what is 3 to the power 5 divided by 3 to the power 3, well, let's do expansion. 3 to the power 5 is 3 times 3 times 3 times 3 divided by 3 times 3 times 3, 3 times. You see how it is 3 times here? Well, what starts happening? Let's cancel. Before we do our solution, we don't do 3 times 3, 9 times 27. That's too much. Let's simplify first. Cancel, 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 and you're left with 3 to the power 2. And this is no magic. 3 to the power 5, 3 to the power 3, is equal 3 to the power 2. You can say 3 to the power 5 divided by 3 to the power 3 is 3 to the power 5 minus 3. The exponents is getting subtracted, equal 3 to the power 2. That gives us the general answer that if I have x to the power a, any x in the world, any a in the world, divided by x to the power b, it will always be x to the power exponent a minus b. And the reason you can think of it is that numerator is x multiplied itself a times, denominator has x multiplied itself b times, and b of those will get cancelled. So the three most important properties of exponent that I want you to remember. One, let's write this down. X to the power a simply means x times x times x. Keep on doing it and you'll do it with a times. You'll do it 8 times, right? And x could be plus, minus, fraction, decimal. It could be any number in the world, right? And by the way, I want to be very, very, very clear on it. This is not 9. This we are talking is a. Okay, that's one property. By the way, example of this will be x to the power of 0 of anything is 1, regardless of what x is. Okay, so that's 1. Second is x to the power exponent a multiplied by x to the power b is x to the power a plus b. And the third one is x to the power a divided by x to the power b. Doesn't matter what a and b are, x to the power a minus b. Okay, so one real life example, we'll talk about it, and then we should be done. This is the example you did actually. 3 to the power 7 divided by 4 times 3 to the power 5. Do not do 3 times 3 times 3. Don't calculate. You can right off the bat say, when I divide with the same base, it's going to be 3 to the power 7 divided by 3 to the power 5 is going to the power 3 to the power 7 minus 5, which is 3 to the power 2, which is 9. So in this equation, this whole thing is not a huge expression. It's simply 9. And then you have to get 4. 9 over 4, that is 2 1/4, or 2.25, or 225%. Right? Let's take another example. 5 to the power 6 multiplied by 5 to the power 3 divided by 5 to the power 2. Well, the numerator will become 5 to the power 6 plus 3 over 5 to the power 2. And that becomes 5 to the power 9 over 5 to the power 2. And that becomes 5 to the power 9 minus 2 equal 5 to the power 7. Does that make sense? Okay. One or two more examples. Let's see one more example. What is the square root of 64 divided by 8? Well, and by the way, we haven't talked about roots, but you know that if I say x squared, it means x times x. When I say square root of some number, let's say I say square root of 64, it means I'm looking for a number which multiplied by itself will give you 64. The square root of 25 is equal 5, right? So square root of 64 over 8, you can simply do the division. It's simply square root of 8, right? What is square root of p to the power 6 divided by p to the power 2? I'll keep the square root. This inside become p to the power 6 minus 2, because when we do division, we do subtraction of the exponent. It becomes square root of p to the power 4. Well, what number multiplied by itself gives you p to the power 4? Well, it is p to the power 2, because p to the power 2 times p to the power 2 will give you p to the power 4. So this is exponent, and this is very helpful, and I'm sure you now understand it solid. Bye.